option for 3 by 3 systems, we will always use elimination. So the elimination that we're going to use is called Gaussian elimination. So Gaussian elimination has 3 rules. We can, 1, interchange any 2 equations. 2, multiply any equation by a non-zero constant. And 3, add any non-zero multiple of any equation to any other equation to replace it. So this is really the same rules that we were using when we did elimination before, with one addition. When we had only 2 equations, interchanging 2 equations wasn't very helpful. So now, if we have rules, we have to have a goal, right? So we have these rules, so what do we want to do? The goal of Gaussian elimination is to convert our general system to a triangular system. So if we have 3 equations and 3 variables that looks like this, our goal is to convert it into a triangular system. So what that means then, when we look at this, we are going to eliminate the x from equation 2 and equation 3, and we are going to eliminate the y from equation 3. Doing so will create our triangular system. So we are going to have to eliminate at most 3 things to do Gaussian elimination. All right, so I know that's not super clear right now, but an example is the best way for us to take a look at this. So let's go ahead and look at example number 1. So our goal is to solve this linear system. So to do so, the first thing we're going to need to do is go from this form right here to our triangular form. So that means we need to eliminate x in equation 2 and equation 3, and then we need to eliminate y from equation 3. When we're doing Gaussian elimination, we always work from left to right in our columns. So we'll eliminate the x's first. After we've done all the x's, we will then start to eliminate y's. All right. So now, just to be very explicit, I'm going to label all of these. So this is equation 1, this is equation 2, and this is equation 3. So I will write my system down here. So equation 1 is 3x plus 3y minus z is equal to 4. And we have 4x plus 2y minus 3z is equal to 4. And x minus 2y plus 3z is equal to 11. So the first thing I'm going to do is interchange 2 equations. So by rule 1, I can interchange any 2 equations. So I am going to interchange equation 1 and equation 3. So when I do this, that means equation 3 is going to become equation 1, and equation 1 is going to become equation 3. You might be asking yourself, well, why would he want to do that? The reason I chose to do that is then my equation 1 is going to have a coefficient on the x of 1. That will make elimination easier. It's not necessary, but it will make our life a lot easier, as you're going to see. So when I interchange them, my new equation 1 becomes x minus 2y plus 3z is equal to 11. All right, that's 1. My equation 2 remains unchanged, so it's 4x plus 2y minus 3z equals 4. And my new equation 3 is my old equation 1, so it's 3x plus 3y minus z is equal to 4. So now, the next thing I need to do, we want to get to triangle form, is I need to eliminate these two things here. So let's start with this. So to eliminate the 4x in this, I need to have equal but opposite coefficients on my x's. So I am going to do the following. Negative 4 times equation 1 plus equation 2, and I'm going to use that to replace equation 2. So this is my rule number 3 for Gaussian elimination. It says add any non-zero multiple of any equation to any other equation to replace it. So I'm going to multiply equation 1 by negative 4, add it to equation 2 to replace equation 2. When I do this, the only equation that gets replaced is equation 2. So negative 4 times equation 1 is going to be negative 4x plus 8y minus 12z is equal to negative 44. Equation 2 is 4x plus 2y minus 3z is equal to 4. And I'm going to add those guys up. So my x's eliminate as I wanted. 8y plus 2y gives me 10y. Negative 12z plus negative 3z is negative 15z. And negative 44 plus 4 gives me negative 40. This is my new equation 2. So I'm going to replace equation 2 with my new equation 2. So equation 1 doesn't change. It's still x minus 2y plus 3z is equal to 11. My new equation 2 is 10y minus 15z is equal to negative 40. And equation 3 didn't change. It's still 3x plus 3y minus z is equal to 4. All right, so I've eliminated the x in equation 2. What else do I need to do next? I need to eliminate the x in equation 3. So now, to eliminate this x, I'm going to need to multiply equation 1 by negative 3. So negative 3 times equation 1 plus equation 3 to replace equation 3. So negative 3 times equation 1 is negative 3x. Negative 3 times negative 2 is positive 6y. Negative 3 times positive 3z is negative 9z. And that is going to equal negative 3 times 11 is negative 33. Equation 3 didn't change, so it's 3x plus 3y minus z is equal to 4. And I'm going to add those two equations together. My x's eliminate as I had planned. 6y plus 3y gives me 9y. Negative 9z minus z is negative 10z. And negative 33 plus 4 is negative 29. And this is my new equation 3. So now my system is, equation 1 didn't change, so x minus 2y plus 3z is equal to 11. Equation 2 didn't change, it's 10y minus 15z is equal to negative 40. And then now my new equation 3 is 9y minus 10z is equal to negative 29.
Professor?
We need to eliminate y in equation 3, and this time we don't have 1s, we have a 10 and a 9. So what is the least common multiple of 10 and 9? 90. So when we do our elimination this time, I'm going to do negative 9 times equation 2 plus 10 times equation 3 to replace equation 3. So negative 9 times 10y is negative 90y. Negative 9 times negative 15 is positive 135z is equal to negative 9 times negative 40. 9 times 4 is 36, so we get positive 360. Now we have to do 10 times equation 3. So 10 times 9y gives me positive 90y. 10 times negative 10z is negative 100z. And 10 times negative 29 gives me negative 290. And then we're going to add these two equations together, just like we did in the previous ones. So our y's eliminate as we had planned, and then we have 135z minus a plus negative 100z gives us 35z, and 360z plus negative 290z is equal to 70z. So finally, we now have our new system. Equation 1 didn't change, so that's x minus 2y plus 3z equals 11. Equation 2 didn't change. We were only replacing equation 3, so we have 10y minus 15z is equal to negative 40. And finally, our new equation 3, once again, is going to be 35z is equal to 70. So now, after all of that, we have it in triangular form. So we've reached our goal. So this is triangular form. So after we have our system in triangular form, we need to solve using back substitution. To solve for our ordered triple x, y, z, we use back substitution. So what we do is we solve the last equation for its unknown. So the reason we needed a triangular system is when you look at equation 3, how many variables are present in that equation now? Just one. And we know how to solve that equation. So we need to solve 35z is equal to 70. So we divide by 35, we divide by 35, and that gives us z is equal to 2. So then we use z equals 2 and equation 2 to solve for y. Because if we look at equation 2, how many variables does it have in it? 2, y and z, but we know what z is because we found it in the previous step. That's why this is called back substitution, is we're going to be using what we found in the previous step to proceed forward. So equation 2 is 10y minus 15z is equal to negative 40, but we know what z is. So if we use z is negative 2, we have 10y minus 15 times 2 is equal to negative 40. That gives us 10y minus 30 equals negative 40. So we add 30, and that gives us 10y is equal to negative 10. So then we divide both sides by 10, and that gives us that y is the same as negative 1. So now we use z equals 2, y equals negative 1, and equation 1 to solve for x. So equation 1 is x minus 2y plus 3z is equal to 11. But we know z is 2, and we know y is negative 1. So that gives us x minus 2 times negative 1 plus 3 times 2 is equal to 11. So then that gives us x plus 2 plus 6 equals 11. So that's x plus 8 equals 11. We minus 8, we minus 8, and we get x is equal to 3. So now finally, if we have x equals to 3, we know that our ordered pair are x, y, z. We have our x, our y, and our z. That is, the solution to this linear system is 3, negative 1, and 2. So that would be the solution to our linear system, is 3, negative 1, and 2. All right. So let's just verify really quick that this is indeed a solution. Because if this is a solution, if I plug that in for x, y, and z in each of these three equations, I should get something that's true, right? So if I turn on my calculator and give this a shot, if I go 3 times 3 plus 3 times my y is negative 1, not plus, minus z, which is 2, when I press enter, I should get 4. And indeed I do. So that checks equation 1. 4 times 3 plus 2 times negative 1 minus 3 times my z, which is 2. And when I press enter again, I should also get, for equation 2, positive 4 again. And lastly, if I go 3 minus 2 times y, which is negative 1, plus 3 times 2, when I press enter this time, I should get 11, right? And if I check, I see that indeed that is a solution to this linear system. So if I plug my x's in, and then I plug my y's in, and then I plug my z's in, I see I get exactly what I'm supposed to get. So we found the ordered triple that when substituted into that linear system makes the equation true. All right. So example 2, a quadratic function is given by f of x equals ax squared plus bx plus c. The table below lists the sales of winter sports equipment and apparel and accessories in November in 3 recent years. Use the data to find a quadratic function that gives the snow sport sales as a function of the number of years after 2006. Then use the function to estimate the snow sport sales in 2009. So this is an input-output table. So it tells us that in year 2006, which is our input, is 0. So that says f of 0 is going to have the corresponding output 296. When I put in 1, f of 1 has the corresponding output 423. And f of 2 has the output 402. Well, these are really just ordered pairs, right? If we remember right, this is the ordered pair 0, 296. This is the ordered pair 1, 423. And this is the ordered pair 2, 402. So that means these are x's and y's, right? We're told that f of x is ax squared plus bx plus c. We're going to solve for a, b, and c. So if we use our first ordered pair, which is f of 0 equals 296, this tells me that 296 is equal to a times 0 squared plus b times 0 plus c. Because I'm replacing my x with 0, and I know that my output f of x would have to be 296. F of 1 equals 423 gives me my output 423 is equal to a times 1 squared plus b times 1 plus c. My last ordered pair is f of 2 is equal to 402 gives me 402 is equal to a times 2 squared plus b times 2 plus c. Well, let's go ahead and simplify this up a little bit and write down our linear system. So 0 squared is 0, and anything times 0 is 0. So my first equation is going to be, well, 0 times anything is 0, 0 times b is 0. So I'm going to get c is equal to 296. My second equation, well, 1 squared is going to give me 1. And 1 times a is going to be just a. So my equation 2 is a. 1 times b is b plus c is equal to 423. my equation 3 is going to be, well, 2 squared gives me 4. So 4 times A is 4A. 2 times B is 2B. Plus C is equal to 402. So this gives me my system of linear equations. So, what am I going to want to do first? Well, my goal is to get it into triangular form, right? So, when I'm in triangular form, in equation 3, what's the only thing that's not eliminated? The last variable. So the first two are missing. So when I look at this, which one of these am I going to want to be equation 3? That's this one. So I'm going to interchange 1 and 3. When I do so, my new equation 1 becomes 4a plus 2b plus c equals 402. We didn't do anything to equation 2, so it's a plus b plus c equals 423. And equation 3 is c equals 296. So now, to get this in triangular form, what am I going to need to eliminate? Well, I need to get rid of the a in equation 2. So what am I going to need to do in order to do that? Well, I'm going to need to multiply equation 2 by -4. So I'm going to have 1 plus 4 times equation 2, -4, to replace equation 2. So my equation 1 is 4a plus 2b plus c equals 402. If I multiply equation 2 by -4, I get -4a minus 4b minus 4c is equal to 423 times -4 gives me -1692. I add these up. My a's eliminate. 2b plus -4b is -2b. C plus -4c is -3c is equal to this plus 402 is going to give me -1290. And that is going to be my new equation 2. So then my system is 4a plus 2b plus c equals 402. And I have my new equation 2 is -2b minus 3c equals -1290. And my equation 3 is c equals 296. And now I'm in triangular form. So I have my goal. So now that we're there, I can do my back substitution. So my last equation, I don't need to solve anything. C is 296. And in equation 2, I have -2b minus 3 times 296 equals -1290. So I go -3 times 296 gives me -888. So -2b minus 888 is equal to -1290. So then I have -1290 I'm going to add to it 888. So I add 888, and I add 888. So negative 1290 plus 888 gives me negative 402. Those go away. I get negative 2b. So then I divide by negative 2, and I divide by negative 2, and I get b is equal to 201. And finally, we substitute into the very last one, which is equation 1. So I have 4a plus 2b plus c is equal to 402. So on the right-hand side, I have 2 times 201 plus 296 to simplify. So I get 4a plus 698 is equal to 402. So I minus 698 and I minus 698, getting 4a equals 402 minus 698 gives me negative 296. Divide by 4, and that gives me a is equal to negative 74. So that gives me a equals negative 74, b is 201, and c was 296. So we go back to our original problem, and it was a, b, and c were the coefficients of f of x. So our quadratic model is f of x is equal to negative 74 x squared plus 201x plus 296. So we were asked then, after we have our model, it says then use the function to estimate the snow sports sales in 2009. Well, 2009 will correspond to the input x equals 2, 3. So we're going to need to find f of 3. Is negative 74 times 3 squared plus 201 times 3 plus 296. So negative 74 times 3 squared plus 201 times 3 plus 296 gives us 233. So, and if I remember correctly, it is in millions, right? So in 2009, there was 233 million in sales. All right. Our next example, is Jude earns a year-end bonus of $5,000 and invests it in 3 one-year investments that pay $243 in simple interest. Part is invested at 3%, part is invested at 4%, and part at 6%. There is $1,500 more invested at 6% than 3%. Find the amount invested at each rate. Okay, so we need some variables. We're going to let x be the amount invested at 3%. We're going to let y be the amount invested at 4%, and we'll let z be the amount invested at 6%. So now that we have that, we're going to be using our same model that we did before. I is equal to P times R times T. So based on what we saw before, we're going to use this model, but we have 3 variables. So we're going to need 3 equations. So what do we know? Jude earns a year-end bonus of $5,000 and invests it in 3 one-year investments. So if x is the amount at 3%, y is the amount at 4%, and z is the amount at 6%, we then have that x plus y plus z has to equal the total amount invested, which is $5,000. So that gives us one equation. The next part says that the 3 one-year investments paid total $243 in simple interest. Well, the interest from the x account, well, if there's x dollars in it, at 3% is going to be x times 3% times 1 year. So we're going to get 0.03x, that's our interest from the 3% account, plus 0.04y, that's our interest from the y account, plus 0.06z, that's our interest from the 6% account, and all together that should give him $243. Because that's our P times our R times our T. So that's 2 equations. Now there's one last thing we're going to need. It says there is $1,500 more invested at 6% than at 3%. So 6% is z and 3% is x. I'm going to write down something I know is not true, which is x is equal to z. And I know that's not true. But we're told that there is $1,500 more invested at 6% than 3%. So that means z has to be bigger than x, because there's more money at 6% than there is at 3%. So in order to make these two things equal, I have to do something to that equation. So I either have to make x bigger, or I have to make z smaller. So since x is the smaller of the two, and there's $1,500 more invested at 6%, to make that equation true, I would have to add $1,500 to x. So x plus 1,500 would be the same as z. So now I have 3 equations. One for the total amount, one for the total interest, and one that puts these together. So my equation 1 is going to be x plus y plus z equals 5,000. Before I put my equation 2 in, I want to eliminate my decimals. So what would I need to multiply everything by in my equation 2 here in order to make there be no decimals? So I would have to multiply everything by 100. And that would give me the equation 2 of 3x plus 4y plus 6z is equal to 24,300. So equation 3 here isn't in the right form. We need to have all of our variables on one side and all of our constants on the other. So I would need to minus 1,500 and minus 1,500, and at the same time, so minus 1,500, I would have to add, or minus z from both sides of this equation as well. So when I do this, I would end up with those eliminating and those eliminating. X minus z is equal to negative 1,500. The reason we need to do this is all of our stuff needs to line up in our columns as we're doing Gaussian elimination. So I would have x minus z is equal to negative 1,500. And that would be my system of equations that I'm going to need to solve. So now I'm going to do negative 3 times equation 1 plus equation 2 to replace equation 2. So that's negative 3x minus 3y minus 3z is equal to negative 15,000. And I don't need to do anything to equation 2. It's 3x, 4y, plus 6z equals 24,300. And we add these together. Our x's eliminate as they should. Negative 3y plus 4y is y. Negative 3z plus positive 6z is 3z. And negative 15,000 plus 24,300 gives us 9,300. And that's going to be my new equation 2. So that gives me x plus y plus z, still the same as 5,000. My new equation 2 is y plus, oops, I have a typo over here, 3z is equal to 9,300. And equation 3 didn't change. It's still x minus z equals negative 1,500. Well, now I need to keep on eliminating, so I'm going to do negative 1 times equation 1 plus equation 3 to replace equation 3. That gives me negative x minus y minus z equals negative 5,000. And equation 3 is x minus z equals negative 1,500. I add these equations together. Those eliminate. I get negative y, negative z plus negative z is negative 2z is equal to negative 5,000 plus negative 1,500 is negative 6,500. And that's going to be my new 3. So my system is now x plus y plus z equals 5,000. Equation 2 didn't change, so it is still y plus 3z equals 9,300. My new equation 3 is negative y minus 2z is equal to negative 6,500. So now I need to eliminate the y in equation 3, and our y coefficients are already equal but opposite, so it's just equation 2 plus equation 3 to replace equation 3. So I have y plus 3z equals 9,300, and negative y minus 2z equals negative 6,500. We add them up, our y's eliminate. 3z plus negative 2z gives me z is equal to 9,300 plus negative 6,500 gives me 2,800. So finally, we get x plus y plus z is 5,000. Equation 2 is y plus 3z equals 9,300. And our last equation 3 is z equals 2,800. So, all right, well, z is 2,800. So then y plus 3 times 2,800 is equal to 9,300. So we go 3 times 2,800 gives us 8,400. So y plus 8,400 equals 9,300. We minus 8,400 minus 8,400. We get y is equal to 900. So then our last equation is x plus y, which is 900, plus z, which is 2,800, equals 5,000. 900 plus 2,800 gives us x plus 3,700 equals 5,000. We minus 3,700, minus 3,700, and we get x is equal to 1,300. So then, that would tell us that there is 1,300 invested at x was 3%, our y was 4%, so 900 at 4%, and then our last value is 2,800 at 6%. And that would be the amount invested in each account.